The last two questions from the homework assignment on chirality. I've got a few emails regarding those about how to identify a chiral center. And I think the challenge is they give you the structure without indicating how many carbons and hydrogens are there. But we need to remember, if we look at this carbon, for example, these two carbons, we need to remember that carbon needs to have 4 bonds total. So I've got a carbon there, carbon, carbon. And so if I look and just focus on this ring, I can see that this carbon here already has 4 bonds. It's a double bond to oxygen, 2 single bonds to another carbon. These sp2 hybridized carbons in the double bond, they have 3 carbon-carbon bonds, and then they need to have 1 carbon-hydrogen bond to ensure that carbon has 4 bonds total. So to have a chiral center, we need 4 different substituents, 4 unique substituents attached to that carbon. So it's just a matter of looking around the ring and seeing where do I have 4 different substituents. And so it might be easier to look at the full structure I drew over here to kind of indicate all the different substituents off of a carbon. So one thing we said, sp2 hybridized carbons cannot be chiral because they're in a double bond, so they only have 3 different substituents. So that eliminates some of these in the first ring. If we keep looking around, right, 2 hydrogens, that cannot be chiral. But if we look up here, this carbon is bonded to 4 different carbons. All 4 of those carbons are unique, so that would be a chiral center. The carbon adjacent to it is also a chiral carbon. It's bonded to 3 different carbons and a fluorine, making that unique. The carbon, 2 carbons adjacent to this one, this carbon is also chiral because it has 4 different substituents. It's bonded to a carbon, it's bonded to a carbon, it's bonded to an oxygen and a hydrogen. And if we look down here, this carbon is also chiral. 4 different carbons are connected to that. 4 unique carbons are bonded to that. The carbon adjacent to that is also chiral because 4 unique carbons are bonded to that. And this carbon, and this carbon are all chiral carbons. So in total, 1, 2, 3, 4, 5, 6, 7, 8. I count 8 chiral centers. So what we're looking for a carbon that is sp3 hybridized that has 4 unique substituents. And so going back into the original structure, it might have been hard to see, but just looking at some of those chiral centers, right? There's a carbon there, a carbon is there, a carbon is there. In some of these, it's very easy to see, okay, 1, 2, 3, 4. That's 4 different branches off of that carbon. It has to be chiral. Same here, 1, 2, 3, 4. 4 different branches off of that carbon. It has to be chiral. Here, they haven't shown the hydrogen. So I just drew that in over here in the second structure. Maybe that helps to see that, yes, at this carbon, I've got 1, 2, 3, 4 different substituents, and that is a chiral center. The next structure, we're asked the same question, identify the number of chiral carbons. And so I just also, for this structure, drew the full structure as well to indicate all of the carbons and hydrogens. But again, we're looking for the same thing. I'm looking for a carbon with 4 unique substituents. So again, these sp2 hybridized carbons, right, they are not going to be chiral. As I look around the ring, right, oh, I should have a hydrogen here. I should have a hydrogen here to make sure that that carbon has 4 bonds. So if I look at this carbon has 4 unique bonds. This carbon has 4 unique substituents, branches off of that carbon. The same can be said for this carbon. This carbon as well, it's got 4 unique substituents. This carbon, again, carbon needs to have 4 bonds. It's got 3 carbon-carbon bonds, so there must be a hydrogen that's there as well. So that adds another chiral carbon here. And again, here, I'm missing a hydrogen there. It's not shown, so that would also give me 4 unique substituents, a chiral carbon there, and a chiral carbon here as well, for the same number of 8 chiral centers. And we can look over on the second structure to kind of confirm that those chiral carbons we identified have 4 unique substituents, right? This carbon here is connected to 4 different carbons, right? 3 different carbons and a hydrogen. The same can be said about this carbon, 4 unique substituents, this carbon, this carbon, this carbon, this carbon, and these 2 carbons up here. All have 4 unique substituents. So that's what we're looking for to identify chiral centers. And yes, I agree it might have been harder given this structure because this structure is assuming you know that at each of these places I have a carbon, and carbon needs to have 4 bonds. So I haven't shown it, but okay, this carbon has 2 carbon-carbon bonds. Then I can assume it has 2 hydrogens that aren't shown. And so that's why I drew or gave you the full structure here, just to show you all of those hydrogens that are basically missing from the first structure that we're assuming you know are there because carbon needs to have those 4 covalent bonds. So hopefully that helps identifying chiral centers, right? We're looking for a carbon center that's sp3 hybridized with 4 unique substituents. So hopefully that helps give you an idea of what we're looking for in identifying chiral centers.